So Rob, if you're ready, I'll stop sharing. And if you want to kind of share a little bit, we can just jump in and Q&A when those things come in. Thank you so much. I'm really excited. This is our first inaugural binational summit of the Sea of Cortez and Laguna Salada restoration, as well as the Salton Sea. So it's really elevating the conversation.
Good morning, everyone. My name is Rob Simpson, Director of Development for Aegis Inc. And just like Nathan, we are very excited to start and really host the Tres Lagunas discussion. What I'm going to do is, number one, kind of show you a little bit about how to use Google Earth and what we can do with it. What you're seeing here is traces of the Colorado River Basin and the Sacramento San Joaquin River Basin. So, you can put maps up on it and just, trace those out. Or you can really take time and go around and trace out using elevation data. One thing of importance is to understand that this river basin is about 4.5 times the size or footprint of this river basin. Initially, this one had maybe 28 to 30 million acre feet a year going out into San Francisco Bay. Today, it has probably about 23 million acre feet. Flows in the Colorado River have always been quite a bit less and have been declining of late. They were maybe around 15, 16 million acre feet prior to the creation of Hoover and Glen Canyon dams for Lake Mead and Lake Powell. As you can see, the chart has a pretty downward sort of slope to it. One thing, as opposed to what occurs as far as precipitation in this basin, has to do with a number of climate forcings, which could include everything from the El Nino, La Nina oscillation, location of the subtropic convergence zone, moisture plumes moving up this direction, as well as sea surface temperatures in the northern Gulf. We don't really have much control over what happens, obviously, for sea surface temperatures there, but we do have a good deal of control of what happens here as far as net annual evaporation / evapotranspiration, net water vapor creation. More specifically, we have, as much as 1.3 million acre feet per year of evaporation from the Salton Sea itself, up to 5 million of evapotranspiration from irrigated lands in the Imperial Valley, the Mexicali Valley, and extending into Arizona. This is the area that was actually flooded in the 1984 flood. If we take all of these terrestrial sorts of evaporation and look at it moving into the future, we could have as little, if we get way carried away with exporting water and reducing irrigation, we could have as little as 4 million acre feet per year by 2050, 2070. If we really start working on using seawater to enhance evaporation, to save the Salton Sea, and reduce the projected amounts of conserve and transfer water to the coastal cities, we could have as much as 12 million acre feet per year from this pink area. If we just look at Laguna Salada and this blue area, this is about 154,000 acres. and would evaporate about 1.2 million acre feet per year. If you look at the power required to evaporate that much water, you're talking about a power plant that requires or converts heat energy into latent heat of vaporization. You're talking about 140 gigawatts of energy per year to evaporate that much water. To put this into perspective, Hoover Dam has a energy capacity rated at 2 gigawatts, so about 70 times as strong as Hoover Dam. A lot of this energy comes from what are called Hadley and Farrell cells. And these are essentially those circulation cells that are consistent with our planet's orbit about the sun, westerlies or wind currents, but Hadley cells, that hot, humid air that ascends around the equator travels northward to about 30 degrees north latitude, which in our neck of the woods is about right here. And from that, hot, dry descending air flows into the Colorado River Basin. And really this system is responsible for most of the deserts that occur in the northern latitude around 30 degrees north latitude. In our particular region, topography, these purple and whites are above 10,000 feet, and they really surround the Colorado River Basin, especially the northern part of it, making it kind of a castle in the sky with a base level down here of about 7,000 feet and the walls being about 10,000 feet. The front door is coming in through this way. Precipitation in the west typically is knocked down by the coastal mountain ranges. But if you're thinking that Gulf of Alaska lows come straight down through this direction and go over like 1, 2, or 3 sort of mountain ranges to make it into the Colorado River Basin, that's generally not how it works. And we'll discuss all these in greater detail. I'm sure the Desert Research Institute and several others will have lots to say on that. But one thing I do want to make clear, this is a Landsat image of our region from the 1984 freshwater flood. We had a really strong El Nino in December of 1982, as well as January 1983, that time frame, producing those atmospheric rivers that collide into the mountains in California. Probably also brought a lot into the Colorado River Basin, but this is a freshwater flood flowing down from the Colorado River Basin and through Coyote Canal. Top elevations here may have been somewhere around the 5-meter range. We're currently collecting greater topography for this entire region, but that is a massive area, and this really defines our playing field. We can do our regular project, and if you're familiar with Google Earth, you can go up to the top of the screen and find the clock, and you can go back in time and see the this is 1985, but that's close enough. One trick we have been using is to use the receding flood levels over the years to give us a good idea, use it as water level. We're looking to generally use about the 1987 level and have about 2 meters above sea level worth of water in Laguna Salada. Yes, we have to put a check dam in here to accomplish that and to provide our downhill flow for our circulation system. It is interesting that, and it's known from folks like those in the Desert Research Institute, 1984 flood produced in June, July, August, about 7 inches of rain, statewide average precipitation in 1984. This had lots to do with a sea surface temperature anomaly. Temperatures were a little warmer, a little earlier that year, and I will let our friends from that particular institution discuss that in further detail. But one thing that really kind of struck me is actually seeing, now looking at those maps of the Hadley cells and the deserts created around the world doesn't really, really prepare you to see the extent of the hot, dry air coming down from these Hadley cells and extending into our region. This is from 7/28/2020. There was actually a hurricane over here, but I'm surprised at how persistent this dry input that really creates this desert is. And yes, I need to do more personal research on that to determine how often throughout the year that occurs. But a lot of the time, instead of storms come, this is a winter storm. This is 3/15/2021. This is when Denver got that big blast. But there's a low pressure here with the circulation this way. There's a low pressure here with the circulation this way. This is actually a continuation of the jet stream, and this is heading up to the north. In general, the monsoon itself needs a low off to the west and a high off to the east, and it can suck in southern Pacific moisture. It can suck in moisture from the Gulf, and it can suck in the Gulf of Mexico, that is, and it can suck in water moisture from the Gulf of California. And the monsoon can extend well up into the western states, and many diagrams even have descending air as part of it. One of the goals of our idea is to balance. We're not going to be able to stop exports from the Mexicali, Tijuana aqueduct or the Colorado River. It would be nice to maintain as much irrigation in all of these areas as possible. But these areas need water too. It is an unfortunate reality of our time. I'm going to leave you with a kind of a big thought. In today's world, matter of fact, all around the world, things like this IMS dredge, which has pinwheels in the back, basically steel vacuum brush in front. This is the IMS dredge 8012 model. They cost about $1 million a piece with all the ups and extras, stainless steel. These are made to work in saline environments, but even adjusting the costs available on their website, paying our 2-man crew $170 in Colorado, making operating costs $300 an hour, adjusting it for Mexico as well, adjusting down the cubic yards per hour. Hey guys, a cost of per cubic yard of 70 cents or in California or 36 cents in Mexico, that is literally dirt cheap. I've managed several hillside communities or the development thereof in California. And if you're not paying $8 or $12 or $15 an hour for traditional grading, $15 per cubic yard, something's not right. Essentially, the hydraulic dredging process is far more cost effective, and these are the perfect sort of tool for the job in our region. You can look this up, just do a search for IMS Dredge, look through their equipment. It's important to note that they have a 35-inch draft at the shallowest. They can dig down as far as 30 feet or 9.1 meters from the water level. And they can be transported on the back of a truck, singular truck. These are pretty easy to launch into environments like the Salton Sea. They can dredge even when the water level is below the elevation of the surface level of the surrounding material. That material can either be essentially ejected, what is that called? Broadcasting to either side, to one side, or exported through a floating 10 to 12 inch diameter pipeline. Without having a booster pump, the dredges are capable of moving at about 2,000 feet through one pipeline. You can have a floating booster pump and create as long of an export process as you want for those solids. And
Hey, Rob,
the factory spec.
Let me jump.
Okay.
Rob, let me jump in there real quick, because I think I really like that you brought this up. When we're talking about the context of a Salton Sea development, a North Lake, a perimeter lake, any of these concepts, the current methodology and thinking is that it has to be a rock and levee lined system, where you're importing material, you have floating barges and mechanical systems that drop that material in, then you're lining it. This is an alternative to that, and it, as was described, is dirt cheap, right? If there's an earthquake event and that salt sink that we have in the Salton Sea is ruptured, we have a small breach, we're able to float that barge back out there and get it done within a few days. That, if you can zoom back out a little bit, Rob, the really interesting thing is that, this project could take, 5 years to build if we only had 4 dredges. But we could get this project built, at least within Laguna Salada. If we had 20 dredges, we could get the project done in a year to a year and a half. So, it's always that conversation about cost benefit analysis. And there's no comparison to doing a system like the Versa Dredge and deploying that, because it is the best tool for the job. And that's really where Aegis comes in. We're in the business of administering and looking in our tool bag and finding this product as it relates to restoration of Laguna Salada and the Salton Sea, similarly to how we're going to be deploying and sharing our other partners and the other industrial groups that have specific technologies for other, insurmountable or seemingly insurmountable tasks.
Thank you, Nathan. Thank you for pointing that out. Just to kind of let you know, we did a bit of an analysis on what it would take to dredge, let's say, from the top of this blue line all the way down here. If we had 16 dredges, build a little, there's a fish camp road right here, build a couple of little extensions where we can bring in a couple of dredges. So you have 2 dredges going down, 2 dredges going up, 2 dredges going down, 2 dredges going up, that sort of thing. 16 dredges working 24/7 for 6 days, which happens to be during a spring tide, how long this entire surface is generally covered with water. Within that 6 days, we could dredge what's called a pilot channel, 2 meters deep, 3 meters wide, from here all the way down to there in 6 days. We'd stack the dirt up on this side. This concentration of flows would induce great back cutting down here. And I don't know if you guys have ever seen this. These little branch-like structures right here are created from water flowing up onto the floodplain and then back cutting, just like Niagara Falls back cuts. Right now, the screen time, you can see it down here, imagery date, 12/30/85. If you just turn off the clock, that screen time goes to 12/29/2020. And you can see that progression of these channels has extended quite a ways north. You can also see a salt deposit haze building up around it. Basically, this entire section down here has become extremely more, this is all salt. Doesn't snow down here. It's funny, or not funny, but this salt extends up here. I'm going to show you that in just a minute. But all you guys can get on Google Earth, download Google Earth Pro. It's free. If you go back to 2009, this is how the estuary looked prior to the Easter earthquake of 2010. In that earthquake, oops, I'm still at 2009. So 2009, 2010, this entire area subsided due to liquefaction. And you're talking 80,000 acres here. Some areas as much as 1.5 meters, others 1 meter, others less. But essentially, when you look down at Coyote Canal, or excuse me, Fish Camp Road, let's turn this clock off. You can see, and they've recently rebuilt this, so I'm interested in seeing more recent, but the tide comes in this direction and then it goes back out in that direction. So we're getting a lot of erosion on a raised elevation. And this is going to be one of our big control point areas, because we really only need to force about 10 million acre feet a year through Laguna Salada to keep it hopefully at 38 parts per thousand. We'll go into more of this in the next days.
Yeah, and Rob, let's
Are we done?
I think I saw a question here. So we'll go to that real quick. And then I know Roger's here if he wants to add any content. So the question that we have was, can you talk about the relationships that have been in development with Mexico and their thoughts regarding the project? So I'll talk about that briefly. And then Mr. Alan Dennis is going to talk about that with Ingenieria Dennis in our next segment. He's going to be stepping up here in about 10 minutes. So overall, we have an introductory relationship with the project as it relates to Mexico. We've met with the local groups. We're working on the meeting with Sermanad and their officials, but we've met with the local agency of Canagua. We've had presentations to their group. We've had presentations to the Kukapa tribe on 3 different occasions. There is an interest level, but additional information is needed. So obviously we're at that point where we need to fund, we need to get environmental analysis and reporting for the Colorado River Delta, for Laguna Salada. So once that information is assembled, that's what we're taking back to those agencies. We have a meeting pending with and requested with SILA, and that's another agency which is similar to the International Water and Boundary Commission. We've had a couple different personal meetings with the State Water Board here in California, and we're really excited to take this overall restoration of the Sea of Cortez and Laguna Salada to the federal government of Mexico. The water that could be generated, the energy that could be generated here, as well as the environmental and economic benefits, far outweigh the cost of development and installation. So I hope that answers that question. We've had several meetings with several local agencies. We're working with the federal agencies now. There has been some miscommunication or misunderstanding about how Laguna Salada restoration would adversely affect the underwater aquifers. And we've studied that in great detail, and that is shown to be on the west shores of Laguna Salada, up above the elevation of the shoreline when it would be flooded. And also it's very interesting that there's what's called a freshwater lens, where when you have ocean water and new fresh water that hits the mountains and rains, that goes down into that aquifer, it's actually held up higher. So those questions are being addressed. We would work with our companies such as like Groundswell. Bring Back the Blue has a good working relationship with Groundswell to do some of these underwater analysis and mapping. And that's the point that we're at. We're stepping into the environmental analysis. We have another question here. What's the profile or standard of the desalination process you are scoping? Is this salt production plant taking salt away from the water and transporting the salt to other region? That's a great question, Caesar. So the desalination processes, we're working with several different companies to look at their technology, figure out if it is the most environmentally sensitive way to do it and the lowest cost to develop that system. There's several different things on the market right now and several different companies. We have one group that's going to be presenting later in the event agenda, but there's geothermal desalination systems. We could do solar desalination systems. These are different groups that could provide that. And the answer would be no, we wouldn't be exporting salt unless we're selling that salt. So if we are selling that salt, that's a way to create a financial mechanism to further the development. Salt can also be used for very interesting products. And Rob, as well as Rob has pulled this up on the screen, we could do a salt drying pond on the west shore of Laguna Salada as well. I think that is developed at 140,000 acres. Is that right?
14,000 hectares is what was requested.
Great, yeah,
which is 34,000 acres.
Yeah, 14,000 hectares, and preliminary return on investment estimates could be in the range of $44 million annually. So we're looking at all different projects, products, systems, as long as it has a net positive benefit to the environment. So hopefully that answers the question. We would offer that to the federal government of Mexico if they needed additional water resources. We have another question. We have South Ranch right at the basin of Laguna Salada. What happened to the locals? That's a good question. We want to engage, and thank you for joining, Jose. We want to engage with all the property owners. We see this as a viable opportunity for us to help, if interested, with new technology, with the type of systems such as seawater farming. And we want to have that benefit those property owners predominantly before anybody else gets paid. We want the property owner, such as the Kukapa tribe that own, the west side of Laguna Salada and Eagle Mountain, to be the primary beneficiary. We're adding our services and our expertise to help launch this project and get it off the ground. So, any services, that need assistance, if your ranch, we could assist any different local agency or local individuals with adding new technology, ways and means to clean your water and recycle that water into your farming systems, as well as new saltwater farming systems. So, it's a balance of having the property owners be the beneficiary. Roger, did you want to say anything? I know you're going to talk a little bit more in the coming agenda. Do you have anything that you wanted to add real quick before we hand it off to Alan? You got to unmute yourself real quick.
Okay, can you hear me?
Yep.
Yeah, I think I just want to make a little comment about the bears on the importance of the increased evapotranspiration. It's one thing to say that it's going to increase the evapotranspiration, and that will increase rainfall in the Colorado River Basin. and it will. But that's not really the end of it. The critical part is really the positive feedback that operates, because once rain falls, it's not just gone, it's in the soil and feeds the plants in the area. And there's a tremendous amount of recycling of water and precipitation. Right now, one of the big concerns about what's happening in the Amazon, for instance, is that the Amazon appears to be in the process of drying out. It's sustained by the feedback loop of all the water that falls one day and evaporates and then falls the next day again. The Colorado River Basin is actually a little bit like the Amazon Basin in the fact that you have the mountain ranges that create a basin effect where you do have a lot of recycling of the moisture. So you increase the rainfall, but that's not the end of it, because that rainfall that you put there comes back again. So you not only increase the rainfall from the increased evaporation and transpiration from the Salton Sea and Laguna Salada, that area, but you also have a wetter climate in general, and you're increasing the evapotranspiration from the plants and the soil in the area. So, and the reverse can also happen. You withdraw water from the system, there's less water there, and the whole system dries out. And it's speculation, but it's possible that a lot of the increasing drought that we're seeing in the Colorado River Basin is the result of withdrawing water and exporting it to an area where it doesn't come back, it doesn't recycle. We're interrupting that recycle loop. So there are a lot of benefits for any increase you can make in the precipitation and rainfall, the import of water vapor from other areas. And when water evaporates, it's not just gone. It sticks around and it comes back, and a lot of it comes back not far from where it evaporated.
Yeah, I just put this up on the screen. This is a result, or images from a study conducted by Dr. Funiglietti and Lowe about 2010-11. And we really need to this was used, they used a global climate model to produce this. We really need to get something a bit more high resolution, but he did talk about the recycling of just monsoonal precipitation, because a lot of times, in the Colorado River Basin, you get thunderstorms that come in, it rains, some of it sinks in, some of it goes into to roots and other such things, or aquifers. A lot of it, though, evaporates. So the same rain that came yesterday might come tomorrow. And, he does discuss a lot of different information regarding that. But, one thing he says, if we stop irrigating the Central Valley, we'll decrease stream flow in the Colorado River Basin. And that when the additional waves of moisture bump into the developing monsoon, said it's like throwing fuel on a fire. Well, that's in this basin. Really, our goal with our experts is to ask the question, hey, what happens if we reduce it in this area? This area we don't have too much control over. This area we have pretty substantial control over. So.
Yeah, and I'll just say there too, you mentioned Desert Research Institute is one of those agencies that's going to be able to provide those regional climate models, but I also wanted to highlight who's on the call right now, Oliver Branch. He's going to be talking as well with the Earth System Solution. They also have their company that's going to be providing a very similar study, and for the purpose of having a validated and multiple different studies to show the results. So we would look at, if we're talking about a paradigm, we would look at a perimeter lake concept and how reducing surface area in the Salton Sea and not having Laguna Salada, what effect that would have on the Colorado River Basin. We would have a restored Salton Sea full to the historic shoreline and what effect that would have. We would have a full Salton Sea, full Laguna Salada, what effect that would have, and then the potential for those green zones of seawater farming, seawater landscape, seawater grass. But really, to wrap up our conversation right now before we turn it to Alan, I really appreciate the time everybody's giving to us. We have this on YouTube and Facebook. If you can't stay on the line and want to check back in later, we're going to have all this content published. But yeah, as Rob's showing right now, you know, there are no viable large-scale solutions to climate change right now. You know, hydroseeding is a concept that might have devastating effects. The use of ocean water in our cities and in our coastal regions, and for the use of food and biofuel, this is the paradigm shift that we're discussing. Ocean water is rising. How do we reduce that rising sea level? By putting it in arid regions, by using it for food and fuel and habitat, you know, in places around the world. And Salton Sea, Laguna Salada, the Sea of Cortez, this is our testing ground. This is a way to show that positive impact on an entire region and an entire, I would say, continent. And this is the purpose of bringing this discussion forward, is that with minimal costs, you know, $200,000, we have two different studies that show these impacts. You know, the Salton Sea Authority, the Natural Resources Agency, this should be a predominant direction that they invest their capital in to show the other projects that they're developing right now. Would that have a net positive impact on this region, or would it have a net negative impact? I think it's a critical element to have that as their very first step in an environmental analysis reporting. So, you know, we hope that regional climate modeling can be taken up with the State Water Board, with the Salton Sea Authority, and we really need the community to talk about that, because that's the first step of a project like this. But it also includes the other projects that propose restoring the Salton Sea. They could all be captured under one study, but none of them go far enough to potentially have this benefit to restoring this region in the Southwest. So with that, I think our time's up. I really am appreciative of everybody jumping in. We got a full agenda shown there in the chat. Follow us along. If you have to jump off, jump back in later. And let's hand it over to Alan. Alan Dennis, are you there?